Hey everyone, in this video I'm going to go over the method I used for successfully converting a modern LED based high beam low beam sealed beam headlamp unit to a first generation Mitsubishi 3000 GT, and it also applies to the same year Dodge Stealth. And the main reason why this is even necessary is because of the way the wiring as well as the triggering occurs for when the headlights are on. To put it simply, it is essentially reversed from the logic used for most other vehicles. In this case, these headlight units are meant to replace primarily truck or semi headlamps. The plug that they come with, right off the bat, is not compatible with the ones integrated into the headlight assembly for the first generation 3000 GTs. However, this headlamps actually come with this adapter, which is supposed to facilitate connecting them to such a adapter because the pattern is a little bit different, and I will show you that here in just a few moments. But essentially, in a nutshell, this is not enough to get things working, and that's also something that I'm going to be going over in just a few moments. So one of the things from a technical perspective, these lights are fairly simple. Essentially, they have a plug with a common ground, and that ground applies to both the high and low beam operation, and two positive leads for both the low beam, which would be the yellow one, and the high beam, which is the red one right here. The high beam or low beam will be energized depending on the setting basically in your vehicle. So if you turn the headlights on by default, then you're going to be energizing the low beam, and then if you switch over or flash your high beam, then the high beam is going to be energized, and then you don't have to worry about the ground because that's always going to be constant. However, it turns out that in the 3000 GT, and this was something that I had to actually spend a little bit of time experimenting and trying to rationalize because I wasn't familiar with it before I went down this venture. The vehicle is sending a constant current, so basically there's a constant positive, which would be essentially reversed from how this operates, and the trigger occurs on the negative for either low beam or high beam. And at first, your mind goes into the simplest mode, which is like, well, I just reverse the wires. But then you start running into the problem of, in the case of a simple harness, like the one that comes in the package with these, and it's actually two of them because it's one per headlamp, that's not going to get you very far. If you basically reverse and put this in one of the positives, and then this basically goes to the negative, then you're going to be effectively operating only one or the other, right? So you can't basically convert them both unless you splice the positives for the high beam and the low beam, and then you're always going to be operating both at the same time. So essentially it's kind of like the catch-22 deal. You can either operate both or none, and that's basically got to make it so that you have to either manually devise a switch for either low beam or high beam, or just live with one or the other. There were some suggestions on how to essentially do a conversion from negative to positive using a relay. So that got my wheels turning, and the information that I found online, which was meant to convert older vehicles, like I think it was like Toyota Tacomas or things like that, to LED, they were not taking into consideration the fact that they were two modes of operation. So yes, they were taking care of the negative to positive conversion, but they were not actually taking into account the high beam, low beam operation or such for an actual headlamp. So that's where my experimentation came into play. What I finally ended up coming up with was, and this is done in Paint, I'm not a electronics engineer or anything like that, so I don't have the ability to do this in professional software. But so basically what I'm doing is I have a representation of the headlamp assembly, the actual pigtail that comes out of the headlamp assembly, the LED headlamp assembly, the plug that's in your vehicle, in your first generation 3000 GT or Stealth, and a 5-pin relay. Although I believe you could probably achieve the same with a 4-pin relay. In this one, I basically retain one of the number 87 pins unused. The other thing is, and this is again from a couple hours of experimentation, is that this was the only way that I was able to devise it in which the low beam was operating at the full capacity. For whatever reason, when I try to do it in the other methods recommended online, I was only getting about half power, or it was about 2/3 of the voltage to the low beam. So the low beam was operating at a very dim rate. So If I zoom in here on my tablet, you've got the representation of your plug on the vehicle. So again, this is using a constant current over here, positive, instead of a constant negative, which is the more common nowadays. And then you've got a negative trigger for both the low beam and the high beam, low beam being the one farthest away from the positive current right there. So what I ended up discovering is that if you grab the relay, and then you've got the relays have pretty standard numbering schemes on them. So if you get a 5-pin 30 amp 12 volt relay, it should match this as well. And they're kind of orientated in the same way for the actual pin spades. So what I did was I grabbed the negative from the low beam, so basically the negative trigger from the low beam from the actual headlight plug on the vehicle, and then I plugged that into pin 86 on the relay, and then I grabbed the positive, the headlight switch, and I plugged that into pin 87, the top one, but also spliced into the low beam on the pigtail for the actual LED headlight itself. And then finally, I did basically a ground to the vehicle from the actual common ground on the LED headlight, and spliced over to the number 85 pin over here on the relay. The final one that's left down here at the bottom is the number 30 pin, and that goes to the high beam positive on the LED headlight unit. So this one is essentially solo, and then the low beam is spliced into pins 87 as well as on the actual headlight switch positive over here. And then the low beam negative trigger over here goes to 86 over here. And then finally the ground coming from 85 here, and then spliced over to both the common ground on the LED assembly here and grounded to some ground point in the vehicle. And what this does is whenever the headlights are turned on, normal mode, then you've got basically power operating. So essentially you've got the low beam receiving power. Power's not going through from 87 to 30. It's basically just maintaining it here. But then when you switch over to the high beam, there's no longer any negative connection, or basically there's no grounded connection here on pin 86, and the relay will switch operations over to allow basically the positive charge or the current to actually flow over to pin 30 and onto the high beam itself, and then it continues utilizing the common ground that goes to the vehicle right here. So this, in essence, the only purpose of this one here is to either allow the operation of the number 30 to flow the current over, or to essentially maintain that closed and allow only the low beam to operate. So you're basically stealing a trigger from the negative side here and making sure that both the low and high beam are basically receiving full charge during the appropriate operation. So that's in essence the diagram that I come up with. Again, it's going to be on the screen in full screen mode, so you can pause it, copy it yourself, do whatever you need with it. But this should get you going. If it's followed to the T, it will work. I tested this multiple times. So, but if you still have any questions about it and how it's wired, feel free to ask in the comment section. Now I'm going to show you basically the harness that I ended up creating, and like all the parts that I ended up like needing to get this going. Okay, so first I wanted to show you again the adapter that comes with this headlamp assembly. It actually comes with two of these, and this is supposed to oversimplify everything. And I'm going to show you the instructions that it comes up with. So these are the instructions that come with the headlamp, and I'll tell you they are probably helpful if you have any modern vehicle, but for this application they're pretty useless. The only reference here that's important is understanding the actual LED bulb side of things, right? But outside of that, this is going to be useless. It even shows the type of connector that we use in our cars, but again, this is 100% bogus, because we're not actually getting ground from here. This is a constant current from this diagonal here, but this actually matches, this little diagram here matches the shape of the plug that we have in our vehicles. It's just that the way this is wired is not going to work. This is actually going to render the headlamp completely unusable. You can try and turn it on as many times as you want, it's not going to work. In fact, I would advise against doing that just in case, because if for whatever reason the LED headlight unit that you're trying to convert doesn't have any kind of cross polarity protection, it might actually burn out. And then one thing I wanted to explain is the reason why this works okay on a regular halogen or incandescent light is because such lights don't have a concept of polarity. They do have a ground, but basically ground flows through through any of the pins. So, okay, so I'm gonna try and draw attention now to this side of the table over here. You're gonna need the plugs that came with the actual kit itself, and then of course you're gonna need a pair of. So you're gonna need 2 of these. Everything that you see here, basically the components that are gonna actually be destined for wiring are going to be doubled up. So you're gonna need the 2 plugs for this, or the converters that came with the unit. You're gonna need 2 5-pin 12-volt 30-amp relays. Those are super easy to find at auto parts stores and all sorts of places. And then you're gonna need obviously wires. 2 colors is fine. You're not gonna be working with a lot of different types of connections here, so I just kind of stick to red for anything that's current or positive, and then anything that's negative or ground, I stick with black. Now try and get, I think this is 14 gauge here. Try and get 14 gauge for all of it if you can. I think I ended up getting a 16 here, a little bit smaller. So at least for the current side, make sure that you get like 14 gauge. You're not dealing with a huge amount of amperage here, but it's always safer to go with a little bit higher gauge. Better be safe than sorry. You don't want to basically cause any melting or fires inside your engine bay area. That would be the last thing you need. And then there's some electronic kits that come with a bunch of, or electrical wiring kits that come with a lot of different like tools and little pieces and stuff like that. So in particular, I'm going to put this aside. You're definitely going to need wire cutters and wire strippers, as well as a crimper tool. So I got this kit a while back at one of the auto parts stores, and it comes with wires and a bunch of like the terminal types and unions and things like that. So that comes in pretty handy. And these kits are usually found for like $20 or so. I'm gonna see if I can find something similar on Amazon. If so, you should see the link down in the description. But if for some reason you don't see a link down there, then just go to O'Reilly's, AutoZone, whichever is in your area, and look for these kits, and they have them en masse. If you're gonna be doing a lot of projects like this, they come in handy. Otherwise, it might be just a kind of an extra expense that you may not want, and then you can buy the parts independently, but they definitely come in handy. And that specific kit actually came with all of these things, minus the black wire. I actually bought that separately for other projects, but it came with all these terminals here. So, and it came with this really handy dandy wire stripper and crimper tool. I actually have an extra pair over here because it's a little bit nicer for cutting, but this one has the crimper for these types of terminals, which comes in very handy. It even has the color coding for the different sizes and stuff. So make sure the kit you get comes with something like that. It'll make your life so much easier. So again, you need 2 of these. You need 2 relays. You're gonna need wires, preferably 2 different colors to make it a little bit easier. You're going to need the crimping tool. And then as far as the terminals go, and this has specific purpose, so you're gonna need 4 spade female type terminals. These are pretty standard size. And I actually use 2 different colors. However, the color coding is usually related to the wire gauge size, so be mindful of that, because it could basically end up like being a little too big and difficult, but this ones will work just fine. But what I'm doing is, these ones are actually pretty big, but I'm using this ones for anything that's positive, and then the blue ones I'm doing it for all the ground and negative stuff. So you're gonna need 2 for the positives, 2 for the negatives, and those are the female spade style connectors, and then you're gonna need 1 male spade type connector for a negative, and you're gonna need 1. These are the spades needed for putting a screw through for grounding, so you're gonna need 1 of those, and this is gonna be the one that's gonna go to your vehicle ground. And then finally, you're gonna need 2 of these guys, and these are the ones that splice your wires together, so you can actually have, there's gonna be 2 separate wires. I'll show you again in the diagram, but there's gonna be 2 that are gonna be spliced together between these adapters and then your ground and your power. I also have Velcro here, the ones that you can just cut to size, and I use that to basically hold this piece and the relay together so that it basically all look like one unit. So in a nutshell, that's all that you need to be able to kind of put this together, and this will net you an actual harness that you can plug in directly to your existing vehicle plug, as well as the pigtail on the LED assembly, and it will have fully functioning low beam, high beam operation, all with the proper amount of current and brightness settings. So I'm gonna probably be using this as reference, but you may also see some flashes on the screen whenever I feel that it might be a little bit easier to convey it that way. But here's the end result. So essentially, if you look at it from the front, you've got the relay and the plug, and I use a Velcro strip to piece them together. That way it's a little bit easier to remove, you know, if needed. You've got the relay down here. You've got the adapter that comes with the headlamp assemblies up here. And again, this is going to be duplicated, so each headlamp assembly is going to require one of these. And then if we look at it from the back, the first thing you're going to notice is this big long ground wire here. And this is actually what I had to do because I used a small one, but I can repair this, so that's not a big deal. In fact, this is, I purposely made this fairly long because it's a little bit easier to find a ground point that way. If you make it a little bit too short, obviously you're going to be struggling to find a proper ground point. But I'm just going to repair this later on. But in your case, if you have the opportunity, just use a bigger loop from the get-go, and that way you don't have to do any repairs on it. I'm going to start with the currents, or basically the current supply, or the positives, and then I'll move into the negatives and the trigger and all that stuff. The shortest wire that you're going to need is basically the high beam going over to the number 30 over here. So this one here to the yeah, so I noticed something that I want to make a correction on. The wiring diagram is not incorrect. However, visually it might be confusing because I accidentally placed the red or the high beam terminal for the LED light on the left side, and then the common ground on the right side, and it should really be reversed. Again, this doesn't affect the wiring, so as long as you color code it properly and you pay attention to the fact that this is supposed to be grounded to 85, ground on the vehicle, and going to the ground point on for the LED assembly, you should be okay. But in actuality, physically, that ground wire is actually over here on the left side, and that positive for the high beam is on the right side. So that correction aside, what I did was basically plug in the high beam from the LED plug end to the number 30 pin here on the relay. And because that was such a short run, I actually reused the existing red wire from the plug itself, and all I did was I basically cut it off, stripped it, and then I put one of these yellow terminals on it. So one of these little guys right here, and that basically gave me that connection from here to here. And this one does not need to be spliced to anything. It's a solo wire that goes from the 30 to the high beam on the plug, and you can achieve that with the existing red wire. Just cut it, strip, and then crimp one of these guys to it, and then it'll actually fit on the spade right here. Okay, so the next one would be our, basically this is the constant current wire that is coming from the actual headlamp assembly. So the way that we achieve that is by splicing the low beam wire from the LED assembly with a wire that will go into our number 87 pin. And the reason why we're splicing that versus just plugging it in directly here is because we are going to plug this one into our vehicle plug on the constant current. And this guy's going to be the one that's going to be supplying constant power to our low beam when the headlights are on, as well as pass it over to the high beam when the relay is triggered. All right, so I had to crank up the brightness a little bit so the autofocus would work. So again, we have the low beam from the headlight, which is the white wire coming from the top terminal here, and that is spliced to a wire that we're going to connect to the number 87 pin on the relay, which is the top one. And this is what's going to be basically giving us that current from the headlamp assembly into our low beam constantly whenever we turn on the lights. And then when we trigger the high beam, which I'll explain again in a few moments, then that current will also go in through that number 87 pin down to the number 30. So we're gonna get power to both. And this is something that I might show on the screen because now this is all bright over there. And then we're gonna start moving over to the actual grounds and negative portions. So the simplest one, I'll start with that one, would be our negative low beam trigger. So that's basically the one that as soon as you turn on the headlights and they're in low beam mode, this guy here, and let's see if the camera picks that up. So this guy here is the one that's actually going to be properly grounded on the vehicle, so it'll detect that ground, right? So that would be a solo single wire that's going to connect to the number 86 pin on your relay, which if you're looking at the relay, the way that normally people look at it, which is with the 87s up, 30 down, 86, 85, it's going to be your leftmost. So solo wire that goes between those two. And the way I shift that over here is basically just gave a kind of a shorter run wire, a little bit longer than the one that we used for the red on the high beam that goes to the 30. So the one that goes to the 86, I essentially just created a short run. I would say it was probably about 7 inches maybe of length. And then on one end, I gave it a female spade connector, which is one of these little guys. And on the other end, I gave it a male spade connector. And this guy, basically you just plug it into your relay and this becomes part of the harness. So this will later on plug into the vehicle. And I'll show you all that stuff as well. And then finally, here's the long one. Not a whole lot of complication, very similar to what we did with the low beam constant current one. So what we're doing is that common negative, which physically is actually on the left side, but you know, here is represented on the right. So that one, what we're doing is we're basically grabbing that and running it and then splicing that into a common ground. And I actually chose two because this one is not going to be the actual connector itself. So this guy here, this is too short, and we're not actually going to plug that anywhere here. This is actually unused completely. Then what I chose to do was splice it somewhere around, basically almost towards the end, just before this connector here, but I didn't actually remove the connector. I'll tell you why in just a second. But I basically just spliced it somewhere around here, and then the actual cable that I'm using, or the wire that I'm using for the ground, I made it fairly long. This is probably about 3 feet long, maybe? No, maybe 2.5. But this one here, basically what you do is you get a wire and you add one of the female spade connectors on it, and then on the other end you don't do anything at the beginning because you have to run it through the to the far end over here. So you run it through first, and then you complete the splice, and then you add to it, you crimp to it a loop connector. And again, as I recommended earlier, try and use a larger one so it's a little bit easier to find a screw that you can actually fit it to. A lot of the screws are a little bit bigger than the size that I used originally, which is this guy here. And so it made it a little bit difficult for me to find a screw that actually ground to. So to recap, we have the relay and the plug that came with the vehicle, or sorry, with the headlamp kit. And you've got the positive coming from the high beam as a solo wire going to the number 30 on your relay. Then you've got the positive coming from the headlight unit plug being spliced, one going to the 87 pin on your relay, and one going to the actual headlight positive constant, which is that diagonal on your 3000 GT or Stealth. Then we've got one negative that's going to be essentially dangling for now because it's part of your harness essentially on your 86 on the relay. And we've got one negative that is basically the common ground that's going to be spliced between the your negative or common ground on your headlight or sorry, the bulb plug, and your number 85 on the relay. And then this grounds over to the vehicle. So that's it in a nutshell as far as the how to create this contraption. Now I'll show you how this actually works as far as the vehicle goes. So it's fairly easy. So what you're gonna do is you're gonna have effectively 3 plugs coming out. You're gonna have a white one that's gonna be for your current or your constant power. You're gonna have a short black one with a spade on it, and you're gonna have a long black one with a loop or some other type of screw connector on it. This one is gonna go into your diagonal constant positive on your headlight plug in the vehicle. This one, the short black one that's by itself, is gonna go into your low beam negative trigger, which is gonna be the farthest one from the diagonal. This one will remain unused. And then this third one is gonna go somewhere grounded on your vehicle. Preferably somewhere where it's gonna be away from fuel lines and things like that, just in case. Finally, you just plug your headlight assembly or your headlight bulb into it, like that. And this will give you high beam, low beam operation properly without having to have a separate switch at full power. And then keep in mind that because we are retaining that this constant current from here, this is already fused in vehicle. So this is leveraging the fuse utilized for the headlight assembly. So you're not actually like trying to, a lot of times if you're creating an adapter that's actually drawing current from somewhere else in the vehicle, 12 volt, you should place a fuse in line just to make sure that you can protect both the headlamp and your vehicle as well. But in this case, we're reusing the appropriate one, so this is actually fused directly to the headlamp one. So that makes it a little bit safer. A couple of other additional tidbits that I want to add. I mentioned earlier that, or I think I mentioned earlier, if I didn't, then I guess I'm mentioning now. This relays, you can find them where they explicitly specify that they are weatherproof. If you find one like so, get it. That would be like the preferred method, because this, where this goes, will very likely see a lot of humidity, especially if you daily drive your car. So definitely do that. If it doesn't explicitly say that, you could seal it up with silicone or crazy glue or something around the edges, just to make sure. But the most important thing is the headlamp assembly inside is full of metal. Like the entire thing is full of like metal. So as you notice, all this is exposed, which is fine if this is completely static and you trust that it won't move. However, I wouldn't, because of all the bumping on the road and stuff like that. So as a good measure, you should probably wrap this in electrical tape, and that way you don't run the risk of it actually shorting out. You'll notice that I have a little bit of electrical tape here. Earlier I said that I was going to mention why I did this. Well, in this case, because this specific spade wasn't, or this wire wasn't going to be reused somewhere around here, I decided that I didn't want to just cut it and remove that spade and then basically just splice this over and then basically have this no longer be usable. So what I did was, in case I needed to experiment with other types of like grounding operations and things like that, I decided to leave that spade component out. What that means though is that this is actually potentially a grounding point as well that could spark if it hits any metal. So this isn't a splice. The actual metal spade is not spliced to this wire at all. It's basically external. However, in order to ensure that it doesn't touch any other piece of metal within the vehicle and cause a spark, I decided to go ahead and tape it up like this. So that's just extra protection right here, and also so it's not like unsightly just kind of dangling around. Well, I hope this was helpful to you guys. I know that if I would have found information like this before I started, it would have saved me a heck of a lot of time. So hopefully it saved you guys some time. So I hope that you guys enjoyed this video. Don't forget to like and subscribe. This is an emergent channel. It's kind of small, but hopefully we get to a point where we can actually knock out some useful videos for you guys on a regular basis. So hope you enjoyed, and thanks for watching.